We always advise that concrete has to be in layers. You do one layer, vibrate it, then you put second layer. But if you put everything in one go, definitely with the time concrete will settle down and will get plus the settlement cracks because of the reinforcement is resisting that particular pest or concrete. This I think we have discussed this. This also compatibility with the cement also major issue for getting a proper bleeding. And sometimes there is a clay in the fine egg affect the performance of your on admixture and setting delay. It's possible because of clay content in your fine aggregate. Next is the temperature of concrete. Why temperature of concrete is important? And temperature is concrete depend upon ambient temperature and temperature of materials and water. And high temperature concrete is not good for structural point of view. So there is a, as I said earlier, is setting time there is a issue. Early strength requirement if is there, that is also, and final strength is the issue. And thermal gradient on mass concrete. So generally we measure most of the time because in Mumbai is okay, we get 30-35 degrees, not a normal. But if you go to the Nagpur, where ambient temperature itself is 45-50 degree, then concrete temperature is goes more than 35 degree, then it is not desirable to pour in that particular temperature. So we have to maintain, use cold water and maintain temperature below 35 degree. It is for normal concrete. But whenever there is a concrete for mass concrete, when you are doing high-rise building, very big raft, about 2 meter, 3 meter depth concrete, having around say 1,000-2,000 cubic meter in one go, where the thermal gradient is taking a major part. So where we have to chill the concrete and always maintain below 28 degree. So that is a totally different subject. We'll discuss on that when you're talking about mass concrete. So, but we have to remember temperature of concrete is also important. And whenever you are maintaining the temperature of concrete using chilled water, or sometimes you use ice flakes also, it is very easy to pump. Is required very low admixture dose because loss of workability is low. So we can save on the your admixture consumption. So that is also possible. So there's a such temperatures indicators are available. So we have to measure that. But when you are going, you should go, take a proper appropriate reading of this particular thing. Now digitals are also available, but one has to remember that it has to be a calibrated. It has to calibrated with the standard calibration agency, and then only we can use those thermometers. Whatever available in the market, don't use directly unless it has carry the calibration certificates. So this is a temperature. Now what has happened is earlier we are using only OPC and other ingredient like sand and coarse aggregate and water. But now concrete has changed drastically for last 15-20 years. I think 20 years rather. Because in 1998, 89 we are used first time M75 grade concrete. We are used OPC microsilica, microfine materials, high range water admixtures, then aggregate. Now mixing of two powders means one cement and microfine material, maybe fly ash, maybe with GGBS. All these ingredients are in powder form. Now mixing this powder form is again a new technology. For that, you should have a appropriate mixer to mix the concrete. We cannot use those tilting drum mixers where there no shear mixing in this. That's why mixing may not be optimized. I'm using word optimized because you'll find if you change your mixing mixer itself with the same ingredient, you'll find the performance is totally different with the respect to fresh concrete properties as well as with respect to final strength levels. So mixing of concrete is very important. We have to understand and find out optimize mixing time for the concrete. There is no standardized time for all mixed proportions we are going to use. So whenever using microfine material along with your OPC and fly ash or OPC with slag, you'll find mixing time has to be increased. You cannot use a standard 30 seconds or 20 seconds. When we are saying mixing time starts only after all ingredients are in. You say all ingredients whatever you are planning to use in concrete are already in the mixer, then mixing time starts. And that may be vary from 30 seconds to 90 seconds. So whenever you're using microsilica along with your other material, the microsilica always comes in granular form. If you see there, they write always it is a densified material because microsilica is very fine material. Average size is 1 micron or 2 micron and very difficult to handle at undensified stage. So for construction industry, it comes in densified stage. So even the densified material is there, there are all small granules composed of number of particles of microsilica. So once you add in concrete, this has to be break and expose all the particles to the hydration of cement. For that you need more work, more mixing time to break those granules. Even crushed sand also a lot of fines are there. If you are not mixed properly, you will find it forms balls, very, very small balls, and some of the cement particles only bound with that without any water. So you will find your workability is totally different, strength levels are low. So mixing up concrete is also very, very important in this. And we'll just have a glance on this because it's a subject itself. Mixing of concrete is a subject itself because we are talking only a normal strength concrete, maybe high strength concrete up to M80. But when you go concrete range up to 150 MPa or 200 MPa, this normal mixing procedure will not work. There's required very high efficient mixers, and those are available today in the market. So this is normally pan type mixer. I'm not talking about normal whatever site you use for site mix concrete, that is tilting drum mixer, which is not suitable for today's concrete. When you are using with admixtures, fly ash, OPC, and other material. Even OPC also is very fine material today compared to earlier cement. And dispersion of your fine aggregates is important in this. And water should go and reach to the each and every particle of cement, then only it will hydrate. Otherwise, it will not hydrate. So mixing is important in this. You'll find here, these are number of blades. This is scraping blade. And this is a hydraulic door where here, this you can see here, and this is opens and discharge the concrete. Now here water is also not put it into the directly by the hose. There's a lot of spray nozzles are there, which sprays the water during mixing and evenly it mix the concrete very properly. So mixer, this is a pan mixer. So this is a very efficient mixer. If you use this technique properly, you will find you can save on admixture, you can save on even cement to achieve same strength of level. Because sometimes you will not mix properly, cement will not hydrate totally, because water has not reached to the particle, you may get only 80% or 90% strength. So 10% potential still there. So that one has to understand as a civil engineer and all this. Now the latest mixers are like this, twin shaft mixer. There's the two shafts are there and it has got spiral one. It is high efficient mixers compared to earlier one what I showed you, that pan mixer. Those are the, and the capacity of this mixer can go up to right from 1 cubic meter up to 3 cubic meter size. One single batch will have 3 cubic meter. So you can imagine very high production can be achieved with this. Now once you have that size of mixer, we cannot use only 1 cubic meter in this mixer. At least we should have 50% mixing capacity of that particular mixer capacity. Because we have 1 cubic meter, we have 2 cubic meter, we have 3 cubic meter, we have only 0.5 cubic meter batch size also. So understand that and accordingly we can act upon. Now mixing time here is lesser than compared to pan mixer, but mixing efficiency is far better in this. Now whenever you're looking at this, these blades are variable. There is a possible that sometimes blades are broken also, or they are already lose their shape and sharpness, then mixing efficiency will be reduced. So regular inspection of this mixer is required. This is a top view of the same mixer. You can see bottom discharge and you'll get 100% discharge from this. The two motors are there and these two shaft. Sometimes single shaft small mixers also available from single shaft mixer. This is twin shaft mixers. See the arrangement of that is like a spiral. So when it mixes, it gives excellent mixing efficiency. See how the mixer is moving the movement. You can see here this way and this is this way. And ultimately the mix moves like this. So very short time you can have excellent mixing of number of powders and you get very low water content for the level of workability requirement. If you use same mix with the normal mixers, what we saw that tilting drum mixers, will find water demand is very high. Admixture demand is also very high. I think next time I'll show that one or two videos for the mixing, how it takes the mixing in the concrete. See, this is the mixing time. We'll have to see the optimized mixing in 30 seconds or at least 45 seconds here. around 98% efficiency is there. You take normal pan mixer, this time goes to 90 seconds to get around 90-95% efficiency. Here is also, if you see, you want 100% efficiency, you required around at least 75 seconds to mix. So normally we never take look at what mixing time they use in the batching plant. As a civil engineer, as a concrete technology, you must understand this, and that you'll find. Another issue is coming with this is if the mixing time is not sufficient, you'll find that you are using now high polycarboxylate admixtures. If the mixing time is not sufficient, they are not dispersed properly. So you dispatch the concrete, you take the slump here, or the flow you take around 500 or 550 flow at the batching plant. And once it is reached to the site after 1 hour, you will find flow has increased. Increase maybe 700, 750. So there is a doubt that they are added water into the. That is okay. That if you add water, definitely flow is more. But if the mixing time is low and the dispersion of admixture is not proper, so whenever we are in transit, it makes and then dispersion takes place, we'll find your efficiency of mixer or flow has increased. So that is also possible. So we have to take sufficient mixing time at batching itself because we are not using dry concrete, we are using wet concrete. So mixing tank is very, very important in this whole process of making quality concrete. Next come to the, once it is reached there, the next is your compaction and consolidation. The purpose of compaction is with highest possible density the concrete removing entrapped air. That is a very simple definition why you do vibration of the concrete. But don't influence by the flow of concrete. If the flow is there, it also needs to be vibrate the concrete with the appropriate time. Except you have a self-compacting concrete. Self-compacting concrete is not advisable to vibrate the concrete. But any other concrete needs to be appropriate vibrating time. This we have discussed how much time to be vibrated in VB time, your compaction when you are talking about this. So there is a internal vibrators that everybody aware of this will also see that needles, and we have external vibrators which generally we use for precast industries or here in the site also where the large members are there or girders you are casting, we put external vibrators, and some of the element can be cast on vibrating table itself. Very big tables, maybe 2 meter by 4 meter size tables at a time. Those elements can be cast in precast industry. Now this frequency of vibrator, I think we had discussed when we are talking about compaction of that particular VB test, where they are given the what frequency is there and what amplitude is there for the vibrators. So whenever we are selecting vibrator, you must see what is their frequency and what is their amplitude. Depend upon your structural member size, you select appropriate size of vibrators. Otherwise, you will get like this, not reach. See, honeycomb like this, it will come because concrete has not, vibration has not reached to the site, that particular level. See this. Now in this, we don't try to repair such concrete. You have to dismantle the concrete. It's very difficult to repair such concrete. And as you know, the columns are very, very important to take a load. It is not easy. This is what we have taken from one of the site. See this flange of your girder. Vertically it has reached, but one location it has not reached. Concrete has not reached. This is the I section. Now these are the basically needle vibrator or immersion type vibrators. So various needles are available, right from 25 mm to 80 mm size, with electric driven or diesel driven engines are there. So depend upon your size of size of your structural member, you decide which diameter of needle you must use, and their frequency and amplitude. See, this is what we are discussed. There are four things you are consider making appropriate choice: is the frequency, amplitude, power, and size. This is important in your vibrator. So whatever vibrator is available, you must not use. Depend on whether you have got only 100 thick wall or 150 thick wall. Don't use 80 needle or 60 needle. Use only a 40 needle. That is very important in this. This is what happens under vibration: honeycomb, excessive entrapped air, cold joints, and subside the cracking. Subsidence of cracking is possible because of the you are not vibrated totally. Then it settles down and we find the horizontal cracks. Then if your over vibration is also not good for concrete, segregation, sand streaks, loss of entered air. Suppose you are using some air entering agent in the concrete for the particular purpose of application, there is a possibility that air is lost. Form depletion is normally possible, and form damage or failure. And most of the site you see find that whenever RCC member we cast, you put the concrete and that vibration fellow is only put on the reinforcement and try to vibrate the reinforcement. With that it should vibrate. That is their belief, but that is bad practice. You should not touch the reinforcement with the vibrator. If you touch that, we'll see that there is only cement paste with around the admixture and bond will lose. There's supposed to be total concrete should be there. So concrete has to be vibrated, not only the reinforcement. Or sometimes they'll put on the shuttering. It will damage the shuttering definitely, and there's a possibility of failure. So this precaution has to be taken for the vibration. It's not because we don't have any proper training to the workers who are handling these materials, vibrators or finishing or compaction. So as a civil engineer, we have to get awareness about the material, what how to handle this equipment and what is the purpose and what you will have do and do don'ts. You have to expose. Take a very small training session before going for this such, because there is no formal education on the vibration of the concrete to the technicians. So that is civil engineers' job to pass on their knowledge to their staff. Then only will get a proper good job. See what happens on effect of this. See here is a properly vibrated mix, and then this is 95%. If you not vibrated properly, see here and then you get lower results if the vibration is not properly. See, percentage wise they are given. So once you get 90%, the strength is like this. If you see the 100%, strength is around this much. Relative compressive strength, percentage wise. So 10%, you lost how much? 75, and this maybe around 40-45% loss in the strength. Only the 10% less vibrations. So that one has to understand carefully and do the vibrations properly. So after casting, compaction, deshattering of the column, at least we should allow for 18 hours. Early deshattering need not modification of the mix. Suppose you want early deshattering 12 hours, you have to modify the mix and it has to develop that particular level. Then only you deshatter the concrete. Otherwise, what happens? There is a general practice that morning 9 to 10 o'clock, people, carpenter will come and deshatter the things. But if you done concrete at the late night, maybe 12 o'clock, they finish the concrete some columns. Morning he will come and start deviating, will find there's a deflection. So that precaution has to be taken. Instruction has to go to the site properly when to deshutter the columns or verticals at least. Slab we know it is required to be done maybe after few days. Honeycombing is there, you rectify immediately, but whenever there is a honeycombing, you ensure that whether it is on surface or it is within the body. Now, how to understand whether within the body or on the surface? So there is a test given ultrasonic pulse velocity. You can do that and find out whether entire column is having issue or only that particular location. And accordingly you act upon. Don't try to repair only on the surface. And adequate curing has to be there for at least for 10 days. Now another issue comes in the your beam and column junctions. Now here reinforcement spacing is okay. Here is also okay, but here what both the side comes and also vertical bar. Now concrete has to go here. Otherwise what happens? You put the concrete here, only slurry will go here, and then we'll have a issue on transferring load from this to junction. So appropriate size of your maximum size of aggregate has to be selected. If you have 20 mm, then better you go with 10 mm aggregate size and use this particular column. Because the concrete here 20 mm is okay because gap is very high. But here if you see, gap is not there, even not 20-25 mm. So better you go is 10 mm size. So such location you have to identify, and appropriate design has to be given, concrete mix design, and cast the particular junctions. Then only we'll have excellent quality concrete or structural member also. I think we'll stop today here.